Let's look at reducing radicals. So today we're going to look at perfect squares, the square root of perfect squares, and the square root of non-perfect squares. So first of all, we need to jot down this table, and this is a table that you should have memorized. So again, you should have these memorized. The square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so on. So definitely jot those down, and those are ones that you should have memorized. Of course, you can use your calculator to find these square roots, but these should be quick recall. You should know these off the top of your head. So looking at the square roots of perfect squares, so the numbers inside of these radicals, 1, 4, 9, 16, those are called perfect squares. They're called perfect squares because when we square root them, we get an integer. So when I square root 9, I get 3. When I square root 16, I get 4. No decimals involved or fractions. So let's do an easy one, number 1. Let's find the square root of 49. So if I reference my chart over here, I can see, ta-da, square root of 49 is 7. That's because 7 times 7 is 49. But today we're going to focus on some that are not quite so easy. We're going to focus on taking the square root of numbers that are not perfect squares. So number 2, let's take the square root of 300. Sorry, let's start with square root of 50. A little bit smaller. So looking at our chart over here, you can see that the square root of 50 is not on it. It would fall somewhere in there. It's between 49 and 64. It's not on our chart. That means it's going to be a decimal. If you were to put it in your calculator, it would be 7 point something. I'm not even sure what it is. So, how do we do that? How do we reduce this radical? We're not going to use a calculator. That's not the point of today's lesson. It's to reduce it in simplified radical form. So how do we do that? It's pretty easy, and I think it's pretty fun. So looking at 50, we want to see what number under the radicals over here, what number is a factor of 50? 1, 4, 9, 16, 25, 36, 49. What number there is a factor of 50? Hopefully you notice that it's 25. 25 is a factor of 50. So, according to the rules of the radicals, I'm allowed to rewrite square root of 50 as square root of 25 times 2, because 25 times 2 is 50. Also, I'm allowed to break it apart into square root 25, square root 2. Now that I've separated them, I can take the square root of the perfect square. Again, over here on our chart, the square root of 25 is 5. So instead of square root of 25, I'm going to write a 5, and then just bring down that radical 2. Square root 2 is not on my list of perfect squares, so it just stays underneath my radical. Let's try a couple more. Number 3. Now let's try the square root of 300. 300 is not on our list. Even if we extended the list farther, which you can, it would not be on the list. So looking at all of the numbers underneath the radicals, find a number in this list that is a factor of 300. Hopefully you quickly saw that 100 is a factor of 300. So I'm going to rewrite square root of 300 as square root of 100 times 3. because 100 times 3 is 300. Then remember, I'm allowed to separate it. The square root of 100 times square root 3. Take the square root of that first radical. The square root of 100 is 10. And then bring down that radical 3. That's my final answer, 10 radical 3. So if you notice, for all of these answers, you're going to have one number that's outside of the square root and one number that's still inside the square root. Let's look at one more example. This one's going to have a little bit of a twist. So number 4, 2 radical, or square root, 108. So we have this extra number hanging out in the front, so I'm going to show you what to do if you ever come into an example like this. So what this means is 2 times the square root of 108. 108 is not on our list. It would fall somewhere between square root 100 and square root 121. So we need to find a number again in our list, on the left side of our list here, that is a factor of 108. This one might not be so easy, excuse me, but it is going to be 36. 36 times 3 is 108. So we can separate 108 into 36 times 3. Separate that out. 2 square root 36 square root 3, just like we did in the other examples. Take the square root of that perfect square. Square root of 36 is 6. So when I write this, I'm going to do 2 dot, which means times, 6 radical 3. And then those two numbers in front, you're going to multiply those. 2 times 6 is 12. Bring down your radical 3, and that is your final answer.